look at question 1b. We have a question such that a 12 centimeter segment of wire carries a current of 4.0 ampere directed at an angle of 41 degrees north of westernly magnetic field. What must be the magnitude of the magnetic field if it is to produce a 5 Newton force on this segment of wire? What is the direction of the force? Well, first and foremost, we need to jot down every parameters that we have. So here we go. What the first one we have L. Okay, the length of the wire we have 0.12 meter. Okay, what else do we have? We have the I. It is 4 ampere, and we have force. It is 5 Newton. What else do we have? And we have the formula to be used equals F equals to I L B sine theta. So first and foremost, we need to try to sketch our situation over here. And if we have, this is north direction, not so straight, but we can work on that. And we have B over here, magnetic field, and we have our I over here, and the angle is how many degrees? 41 degrees. Now let me explain a little bit. Okay, so in this case, what we need to do is that we need to analyze. The ideal condition is that the I should be perpendicular to the B, but in this case the I is not perpendicular. It's about 41 degrees from the B. So to make things simpler, we need to uh, we need to resolve the I into the X component and also the Y component. The X component of I is parallel with the B. We don't want that. The component which is parallel to the B will be equals to 0. Remember our formula, it's ILB sine theta. So sine 0 degrees equals to 0. So we want to find the component of I which is perpendicular to the B, which is 90 degrees from the B, which sine 90 will be equals to 1. So we need to find the I, Y. To make things simpler, let us try to resolve the I. So we have I over here. Okay, I, we can resolve into the IY and also into the IX. And we have over here is 41 degrees. So if we try to make a triangle over here, so we have like this. This is 90 degrees. This is, again, this is I. Sorry, this is IY. This is IX. And this is I. So if we use the formula for sine 41, okay, this is 41. 41 is opposite over the hypotenuse. Opposite means that IY over hypotenuse. And therefore, the IY, we could use IY, modify the equation, rearrange the equation. We got I sine 41. And given from the question, I is 40 ampere. Just plug in the value. So we have not 40 ampere, but 4 ampere. Sorry for that. 4 ampere times sine 41. Sine 41 equals to sine 41 equals to 0.656, and therefore we got IY equals to about 2. Let me hit my calculator first. 2.624 2.624 ampere. So we have our component I sine theta or equals to Iy. We have covered that one. So we have the remaining equation, which is F equals to I L B sine 41. We have covered the I sine 41. So we have LB still unknown. I sine 41 we have calculated, it's about 2.624 ampere. How about L? L is given and F is given. F is 5 Newton. L is 0.12 meter and B is unknown, and we have the I sine theta 2.624 ampere. So can we find B? Yes, we could find B. Rearrange the equation, and finally B we will get about 15.878 Tesla. So this is the magnitude. Don't forget that B is a vector quantity. It has direction as well. So use your let me check for a while. So you need to use your right hand rule. Okay, you need to use your right hand rule. See, this is your right hand rule. Determine the direction of the B, the magnetic field. Okay, this is your right hand rule. How do we use that? So imagine that you have, okay, you need to determine the B, leave it up first. Follow your index finger towards the direction of the current, and your middle finger towards the direction of magnetic field, and finally you will get that the magnetic field, the direction of magnetic field is out from the page. So the thumb should be, your thumb should be directed towards your face. Practice using this, the right hand rule, this diagram. Yeah. All right. That's it for now. Look at exercise number 2.